Hey everyone,
Hello, everyone.
welcome to day 4 of our summit. We have Alex, the CEO of Matter Labs, and he'll be doing a talk on zkSync, why rollups are not enough, and how to fix this. And I'll let him take it from here.
Thank you. Happy to be here. So yeah, we're going to talk about rollups and what we do at zkSync to fix the problems which rollups are like not going to entirely solve. I'm from zkSync, or I'm from Matter Labs, which is a company that built zkSync. And for those of you who are not familiar, zkSync was one of the first zk rollups on Ethereum. We are live on mainnet for over a year with as a payment solution, which many of you might have experienced through Gitcoin grant rounds, but also through many other applications that support payments by now. We have processed over almost 4 million transactions so far, and we have added supports also for swaps and NFTs. And right now, we're focused on delivering version 2, which is going to be the first EVM-compatible zk rollup. We're working on something called zkEVM, which will be an engine that allows you to just essentially deploy existing code from L1 in unmodified form with Web3 compatible APIs, where you have full atomic composability, so everything just works, looks, and feels like you are on level 1, but you still have all the benefits of a zk rollup. And today we also have multiple rollups on Ethereum. The Rollup-centric roadmap has arrived. We can scale cost significantly for transfers. There are optimistic rollups that already support generic computation. But an interesting problem here, as you can see, is the fees for rollups are actually not many orders of magnitude cheaper than the fees on Ethereum. So for optimistic rollups, they're about 10% of the mainnet costs. For zk rollups, we are much better with 1/50th, 1/40th of the costs. But as we go further from here, the reality is going to be pretty complex. So we see that people from L1, and this by the way, we predicted that half a year ago when the rollups just were jumping into production, that people who have large liquidity on L1 are not going to be the fastest ones to jump on L2. They will wait and see how these new technologies play out and how security shows itself, just make sure that these novel solutions are battle tested with time. And meanwhile, we're going to have a lot more new use cases and a lot of users coming from outside of Ethereum, from side chains, from just new retail users who maybe don't care that much about security, but just want to play out with things and try them out. And they are all coming into L2 directly. And this can lead to a situation which we have already observed in the past, that the number of users is growing linearly over time, but the gas fees are growing quadratically. So in nx increase in number of users will be n square increase in the gas fees. And if we look back at where we are now with rollups, if you imagine that the prices go up 10x or 100x, if we have a 10x increase in number of users, we will be actually back to quite significant fees. So if a transfer costs $10 and a simple DeFi operation costs something like $30, $40, $50, we will price out retail users again, and rollups will not fulfill the promise. And we were very concerned about this several months ago already. There are multiple solutions. One would be just to go back to side chains, but this is not in the spirit of Ethereum, and this is not a secure solution. This is not the future. So we need something better. So what we can offer. One thing that is taking off right now and gaining in popularity is called before we go there, let me describe what the long-term goal should be, and that is, once we have sharding on Ethereum, we can use zk rollups with a much improved bandwidth for data availability, and this will probably solve our problem to a very high degree. So we will have over 100,000 transactions per second with full Ethereum security. The only problem, it will take years. The sharding is not arrived yet. We even don't have ETH2 fully, we have not fully transitioned to proof of stake. So once this happens and is stabilized, and once sharding arrives and we finally transition to sharding, it will be at least 3 or maybe 5 years from now. So like, this is a long-term North Star, but this is nowhere, we are nowhere near. So one solution which is gaining in popularity that is available today is Validium. This is, I will describe it as a zk rollups minus on-chain data. So you have all the benefits of zk rollups in terms of that the snarks provides in terms of validity of every transaction, which is enforced by the math and Ethereum network itself. So you can be sure that nothing is going to be stolen, nothing is going to be corrupted, all the contractual logic is going to be enforced. And this is great for big corporations embracing Ethereum because they can rely on these rules being just what they expect them to be, while the data is provided by centralized parties they can trust. Because it's easy to trust a party to just hold the data, like not to disappear. They can have contractual relationships, they do it all the time, and they have very low costs on chain without having to actually verify every single transaction. The problem is the solution is not so great for the end users, for which we in Ethereum are striving to build the future, like empowering the individual to fully take control of their financial assets, of their finance in general. And if we let the centralized parties handle the data availability, then we are actually going to be not very different from a bank. So yeah, you will have some more degree of openness, and you will have more guarantees of security provided by the Ethereum and snarks and math, but you will still have the centralized providers who will tell you what rules you have to observe. They might introduce KYC, AML, might ask you for like some weird questions, start asking you how you spend your money. It's going to be like, we will very quickly go back to a situation which we have with banks now, because there will be this small number of centralized providers which are very easy to pressure by the powerful authorities. So how can we do better than that? And the second short-term solution, which we are implementing in zkSync version 2, which is coming with the very first release actually, is called zkPorter. And I will describe it as a zk rollup with extra chain data. So we solve the data availability not on chain in Ethereum, but we solve it on, we put them on sort of external chain, which is still decentralized. And we have all the other great properties of Validium, which are preserved, such as that every transaction is verified by Ethereum. You have mathematical guarantee of validity. You have much lower costs, but we remain decentralized. And there is no single point of failure, no single authority which can be pressured or pressure you into changing your behavior and becoming a centralized bank-like structure. So in the rest of the talk, I'm going to describe how technically zkPorter works, what limitations it has, and what it means for you as a user. So to explain that, let me first recap how zk rollup works in general. So imagine you have a state tree with a root hash here, with the leaves representing your accounts. Now imagine, imagine we just have like one tree with all the accounts at the leaves. Whenever we have a new block, this means that some of the accounts have been modified. Some users will have transacted, and the sequencer will collect all these transactions and will update the state, modifying the accounts which have changed. And they will recompute the new state root, and they will submit this new state root to Ethereum, which will be stored in a smart contract. If the proof of validity, which the sequencer has to also compute, is valid. So the sequencer will produce this zero knowledge proof of the block, that the block is valid, and they will submit it to Ethereum, and Ethereum will accept it and modify the storage of this rollup contract. Now, for every account that has changed, we will also have to submit the data availability on Ethereum. This is also a job of the sequencer. And this will be also enforced by our proof of validity. So the proof of validity will have to contain the hash of all the public data which we publish as a single blob of data. And we will also submit it to Ethereum together with the data, and the contract will check that the hash of this data corresponds. It's actually included in the snark of our block, so that we actually so this data which we publish actually corresponds to all the transactions that happened in this block. Now, this gives you the exact same security as layer 1, because every transaction is verified, and you can always reconstruct your state from this state updates on mainnet, and you will be able to prove that you own some funds in one of these zk rollup accounts, so you can withdraw even if the operator, the sequencer, goes down and is unavailable. Now, with zkPorter, what we do is we pick a subtree of the state, and we say that all the accounts in this subtree are now zkPorter accounts. So we're not going to publish the state changes for those accounts on the mainnet. So it's essentially just a flag. Like we look, the account is in the right subtree, so it's a porter. We don't have to publish this data. Instead, we only publish the zkPorter root also to the mainnet, which will mean that no matter what happens here, all the zk rollup accounts are safe. You can always reconstruct the Merkle path, for the zk rollup accounts, because there is no path to the zkPorter accounts for which the data would be not available. So this might be complicated, but if you're familiar with Merkle trees, you understand what I mean, right? So for those accounts, and so like we publish the zkPorter root through Ethereum network, but we publish the data availability of this zkPorter accounts to a separate network of stakeholders that we call guardians, where for every new block to happen, we would require the majority of the stake of guardians, this node operators who collect and store data for zkPorter, to sign this data. And by signing it, they will sort of certify that they hold the data for zkPorter accounts, so that if at least one of the signees is honest, the zkPorter account users will be able to reconstruct their state. So the rollup security is not affected no matter what happens here, but of course, if the guardians become malicious, they could do something wrong and will something bad, and we'll see exactly what. So in the Porter accounts, we have, as I said before, all the benefits of Validium. So there is no theft possible. No one can forge new assets, new tokens, new NFTs, like change the state in any invalid way whatsoever. If the minority of the zkPorter guardians become malicious, this will merely constitute a loss of liveness. So we will not be able to provide new zkPorter blocks, and all the users will have to exit. And since it's only a minority, some of them will be like the majority of the users is still holding the data, so they will be able to provide you with your data so you can gracefully exit. Now, if the majority of the stakeholders are malicious, then the zkPorter accounts will be frozen, and they can do an invalid state, a valid state transition without disclosing the data, so that you as a user cannot actually access your funds, which would be a pretty bad situation. Luckily, the attacker's stake in this case will also be frozen. So there's no way an attacker can profit from the situation. They cannot, unlike side chains, they cannot just take your money and get away with it and forget about their stake. They will always have a big loss, and it's going to be a lot of people involved. So someone will have to be suicidal and actually go and purchase 2/3 of the stake, which will cost probably some billions of dollars in the best scenario, in order to freeze your data, which just doesn't make sense. So someone will really have to be this suicidal. So this means you have a lot better security guarantees than side chains, but the theoretical situation still is possible where data is missing. The great thing is every user is free to opt into their own security threshold. So you as a user of zkSync will be able to choose which type of account you want. And if you go for zk Rollup accounts, you will pay something like 100th, 150th of the L1 costs. So the costs will rise, but you will enjoy the full security of Ethereum. If you choose to use the zkPorter accounts, then your costs will be more or less fixed. So you will pay something like 1 cent for a transaction if you are transferring funds between zkPorter accounts or using zkPorter services, while, of course, you're accepting the risks of the freezing of the state, which I just described before. And the scalability, interoperability remains. So scalability will be on the left side, roughly 2000 TPS peak load. This is if our zk rollup was to use the entire capacity of Ethereum, which is unrealistic because we also have other rollups and other transactions happening on Ethereum. Whereas on the zkPorter side, we are essentially only limited by a throughput of our consensus mechanism of our sequencer. So like if the sequencer is centralized, then there is no limit. If the sequencer is decentralized, then the consensus will be a bottleneck, but we can split it again in multiple shards and have multiple different consensus. So the zkPorter is more or less limitless. Like we can have many thousand TPS on the right side. And the most interesting part of zkPorter is that it's fully interoperable with zk rollup accounts. So zkPorter users can send funds to zk rollup accounts and can interact with contracts that reside in zk rollup, such as Uniswap or Balancer or Curve or whatever DeFi applications are available there. And they will be paying, they will have to pay the rollup data availability costs, but those costs will be amortized across all the users that interact with a single rollup account in the same block. So let's say you have zkPorter users who want to interact with the Uniswap on zk rollup, and you have 1,000 swap within one big block that takes place within an hour. Then they will only pay a very small fee for every of these transactions, because at the end they only have to pay a fixed number of slots modified on in this Uniswap. And all of the users, all of these interactions will share those costs. Even if it costed like something like $100 would be in the cost of a normal Uniswap interaction on zk rollup. On the Porter, it will be only 10 cents. And yeah, that's it. Thank you for watching. I'm happy to answer any questions now. Let's make it more interactive. So we have a chat where you guys can post questions, and I will do my best to answer.
I think it might take people some time to think up questions for this, because it's a pretty technical talk and early in the morning. What are some very common questions you get, like when you talk to investors or when you talk to people about this?
Well, everyone is asking when the zkSync is going to be live, and I'm just going to ask you to be a little bit more patient, and we'll have some really exciting news in the coming days.
Okay, cool.
And yeah, a lot of questions are about zkEVM, how zkEVM works, and what limitations we have. And this has been a source of the delay of our launch. So we initially planned to have to already be on mainnet this summer, but we stumbled upon a number of challenges which we decided to solve them properly, and we actually ended up with a much closer EVM compatibility than we originally hoped. So like most things will work just without any modifications. And this includes interoperability with wallets. This includes interoperability with contracts. So everything we are really, really happy about the way the final version of zk EVM is crystallizing. But yeah, we will let people discover it themselves very soon. How does this compare to other L1 solutions like Solana? Well, you have, unlike any other layer 1, the full guarantees of validity of all the transactions through Ethereum. So we derive all the assets from Ethereum, which are natively available in zk Rollup and zkPorter without any need of a separate bridge, which introduces new security assumptions. And you really cannot do anything wrong there. So on Solana, you rely on the validators, and you have, like, on all these big solutions, all these big layer 1s that support very high throughput, your state resides in a very small number of very powerful machines. And there is no way for end users to actually be able to reconstruct the latest state without like having these powerful machines, which leads to very high centralization risks. So as far as I know, on Solana, for example, all of the state is only stored in a Google database. So like if Google decides to shut down the chain, they can totally do it. Whereas with zk Rollup, the state is available on Ethereum. So whoever can sync a full Ethereum node will be able to reconstruct the state and completely access the data. Whereas the zkPorter nodes are optimized for consumer hardware. So you will not need to run a powerful data center with like lots of SSDs and lots of memory in order to be able to become a zkPorter guardian. All you will need is a simple laptop. So because you don't have to store anything in like this high speed SSD memory. All you need to do is to take like a bunch of data and apply them to a simple key value store, and like you don't have to reconstruct the numerical trees. You don't have to do a lot of computations essentially. So you only have to store this data, and you can do it on a normal laptop. And this is why, and your security is not very important. Like if your node is compromised, like nothing bad will really happen to you. You will not be slashed. You will immediately notice that, and you will be able to use your cold wallet to exchange, to fix your security, to reinstall the Porter node, but essentially risks for you are very small. That means a lot more people will be able to become part of the Guardian consensus. So we expect hundreds or thousands of individual participants in the Guardian nodes, which is like orders of magnitude more than anything than the validator sets you have on this layer 1s. So the decentralization of zkPorter is going to be much higher, and the security actually is derived from Ethereum itself on the validity part, at least. Okay. More questions. So does the project need do projects need to migrate into zkSync like other L2 solutions like Arbitrum and Optimistic Ethereum? Yes, all the L2s for projects to benefit from composability, you will need to deploy new instances of contracts on this L2 solution. And for them to interact with other solutions instantly, other solutions also have to be on zkSync. So you can interact with layer 1. You can have batched interactions with contracts on L1 where you send some liquidity from L1 asynchronously to zkSync, then you have a lot of interactions there, you do some trades, and then you send all of this back to L1. But this is going to be asynchronous. So there are use cases for this, and they are very interesting, and they involve a lot of liquidity, and they can only work on zk rollups or Validium, because optimistic rollups do not support instant withdrawal from L2s. But for most applications, let's say, yes, you have to deploy it in zkSync. And we have a large lineup of projects who intend to launch in zkSync. Essentially, from the day we start, we'll launch the version 2. Okay. The guarantees of data availability for guardians are economic. Could the guardians on zkPorter nodes allow off-band data availability proof protocol? I'm not sure what the question means. So can you clarify the question? What is off-band data availability proof protocol? So you do you mean? I'm not sure what this means. I can talk generally about alternative data availability solutions that could be employed. There is something called Adamantium, a solution proposed by Starkware, where it's essentially an extension of Validium, where some users, let's call them power users, can ensure that their data is always available by being live 24/7 and co-signing every block. So those users will be able to not rely on data availability committee of a Validium, but instead they will be their own data providers. Unfortunately, this only works for a small number of users, mostly for corporations, because they have to be online, they have to perform a lot of computations, and this is just not something you as an end user will do. As an end user, you could rely on Adamantium for, you could ask someone to be your power user and provide availability for your data, but this is just adding one more layer to your data availability committee. So this is not actually changing a lot of things. And with zkPorter, indeed, you have economic guarantees, which is worse than zk rollup, but still good enough. As we like, this is the best we can do today. Let's put it this way. So it's a lot better than any sidechain, any other big L1 which is not optimized for decentralization. And there's no way to economically profit from an attack on a zkPorter. But if some really big entity wanted to destroy it, they theoretically could, which I don't think will be feasible I don't think we will see this in any near future, but this is a theoretical long tail risk which you have to take into account. So of course, a zk rollup is the best solution possible, and we all want the sharding to arrive as soon as possible so that we can just let every user switch to zk rollup and have the full control of their data and be fully self-sovereign with their finances. Yeah, any more questions?
Cool, this was great. Thanks, Alex. And thanks for being our very first session of the day.
Fantastic, then thanks for having me. And yeah, very excited for the rest of the summit.
Awesome. We're going to transition to the next talk now. Thanks again.